Hey, hi Nikita, Happy New Year.
Hello, Happy New Year. We first need to have Jason on the call who will be presenting about Go.
Okay.
Thanks for making it, even though I know it's like 9:30 p.m. right now.
Yes, it is. Even like in Delhi, it's so cold. So
All right. Like, what's the weather like?
it's 6 degrees, 7. No. It's in the morning. Now it's 11 or 10.
It's still cold.
It's very cold.
Yeah, I'm in Mumbai right now, so it is
Hot.
warm. Yeah. So Ricardo won't be able to make it today. So I'll be hosting the meeting, but we first need Jason on the call because Jason was going to be presenting about Go. I've pinged him on the Slack channel. Let's see if he can make it. If not, I guess it will be a very, very short meeting today. I guess we'll give another minute before calling it today. I don't see any response from Jason on Slack either. By the way, we don't have many projects in the pipeline for the next few meetings. I'm going to be taking a pass at the projects that we've listed down that we want to invite to this meeting. But if you all have suggestions or if you want to see certain projects present here, please let us know. So he's responded in Slack, so it's probably the original.
Hello.
Hello.
Sorry about that. I did not have a reminder that this was happening, and I forgot that it was happening. So anyway, hi.
Will you be able to present about Go today? Just
Yeah.
take any questions.
Yeah.
Okay.
Yes. Let me find the place, the presentation that I give on this.
Yes.
Here we go. I'm going to do it probably pretty quickly so we have more time for questions. Screen.
Let me know when you're ready, and even though it's like recording already, I can kind of look off the recording officially.
Sure. One second. Share screen. I don't use Zoom very much either, so.
You are muted if you're speaking.
All right, can you see that?
Yes, you can see us.
Okay, great. All right, yeah, I guess I'll get started. Like I said, I'm gonna go through this pretty quickly, so they have more time for questions. The main thing that I think I would like people to take away from Go is that it optimizes for one specific thing. It is trying to make building Go containers easier, because that's sort of a very common thing, and there are some optimizations we can make if we solve only that problem, that you can't make if you sort of have to become a general purpose container build tool, like some others that are out there. So I usually start by saying, like, this is how people are building Go container images today, right? More or less, this is like copied from the official Docker guide for packaging a Go application. You, from Go, run Go mod download, and then Go run build, and then the output of that is a binary that you make your images command. This should, look pretty similar. This is a multi-stage Dockerfile build. It does the same things, except instead of all of that, instead of your final image being based on Go, it's based on a distroless image, and then only that binary is written into that distroless image and made your application. But this is like really fraught, right? Like, there's a bunch of stuff to have to remember to do. There's a bunch of commands that are sort of opaque and difficult to remember the semantics of. A lot of people get these wrong, or at least, like, not even wrong, just like not sure exactly which ones of these things need to happen in which order, and does it make it incorrect if I get them out of order? Does it make it slow and unoptimized if I make them out of order? It's kind of tough. So Docker build for this, I would argue, is a bad fit. If all you're doing is running Go build inside of a container, and then putting that output binary into an image, you don't need Docker build for this. And I think a lot of people waste a lot of time managing Docker files just to accomplish this. So yeah, what are you basically doing? You are running Go build on your app, and then putting that in a layer on top of a base image and making that the image entry point. It's just running Go build. So that's all Go does. When you do Go build, it runs Go build for you exactly like you were doing in the container before. It puts that output into a new layer on top of a base image. We use a distroless base image by default. It makes that the image's entry point, and it pushes that image directly to the registry. I think another thing people usually forget is, like, Docker build doesn't push by default. You either have to do -- push or Docker build and then Docker push, which is kind of annoying. This has some benefits right off the bat. It's just running Go build inside of your regular development environment. If you were running Go build and Go test, you have a Go build cache built up for you, and Go will take advantage of that right off the bat without having to make any other changes. There are some caveats or sort of things that Go assumes about your environment and about your application. It assumes you're not using CGO. There are ways to make it work with CGO if you need CGO, but most applications, including, like, most Kubernetes controllers and most things you package into an application, don't need CGO at all. So in general, that's an optimization we make, but there are ways to support CGO. It uses your local Go toolchain and environment, whatever Go version you're running, whatever Go env you have set up. It doesn't assume, it assumes that you want a single Go binary in an image. And so it doesn't do things like let you run APK add to add more packages. If you need those, you can put those into your base image. We have other tools that make it easy to build base images for you. Yeah, there's an environment variable you set to say where to push that image to. That's another one that people sometimes overlook. Yeah, that's this Go Docker repo. You can say Go Docker repo equals ghcr.io/your username and push to GitHub registry. You have a couple special ones. If you do go.local, it will push directly to your local Docker daemon if Docker is running. So this is good for like local development. Kind.local, if you're running a Kubernetes kind cluster, you can do kind.local and it will push directly to that cluster, which is also kind of nice. So I mentioned, yeah, go ahead.
Sorry, just interrupt. Like I had a couple of questions.
Yeah.
Can I use Go if I'm not just creating images directly from Go code? So like I have some bash scripts or Ansible scripts, a bunch of config files, something like that.
There are definitely things you can do to integrate Co with things like bash scripts. I mean, like most of the time people are doing co-build inside of a bash script that does some other stuff. I'll talk about in a few slides some sort of more Kubernetes integration. But yeah, it's just a command that outputs, you know, the image that was built. So if that's useful for later steps in a pipeline or other things, then yeah, absolutely, it integrates with those.
All right.
Yeah. Anybody? Yeah. Go ahead. Do you have more questions? Feel free, by the way, to
yeah. So the other question I had was like, do you have? I don't know. I mean, I'm pretty sure like it must be really fast compared to Docker, or even other tools like Bitbugs, which use Docker under the hood. But do you have like benchmarks and numbers and how it compares against other tools?
We do and we don't. I mean, I think like you can, in general, things like Docker build can be made to be as fast as Co if you are very careful and very diligent about how your build cache is set up and how, you know, the Docker team has done a ton of work to make things fast because that's a good thing to do. So I would say that it's not so much about who is faster, because that's hard to, it's sort of easy to game that and hard to get a good signal out of it. It's more like, how much work do you have to do for it to be fast? If you just ran that same Docker file that I showed before twice, it would be really fast the second time out of the box with Docker. But when you make a code change, like now it doesn't have the build cache by default, the Go build cache. So it's gonna like have to rebuild more. Yeah, I think like the answer to your question is sort of, it's complicated, but in general, Co should be faster and should be easier to make faster than Docker build and build packs.
Sounds good, thanks.
Yeah, so I mentioned before, like by constraining the problem to just solving Go, we get some benefits, and here are some of them. Auth is handled out of the box by Co. If you can Docker push, you can co-build. We reuse the same auth config, we reuse the same cred helpers. Everything works exactly the same. Co-login is exactly the same as Docker login, just in case you don't have Docker installed. And we compile in a bunch of cloud credential helpers for Google and Amazon and Azure and GitHub, and maybe one more. So you don't even need these cred helpers to be installed. Co acts like you have them installed, which is nice. Like we were mentioning before, speed. Go builds are already really fast. Like Go, that's not Co's fault, that's Go's. So Go builds are really fast, and that's really great. Co does take advantage of your local build cache for incremental image builds. And if you set the co-cache environment variable, we will store even more data in that location to sort of avoid even more work. So a no-op build, like if you don't change a line of your Go code, Co should take about a second to figure that out and not push anything. This is a really good one, actually. By optimizing just for Go, we get multi-platform images really easily. This just relies on Go's built-in cross-compilation support. So if you run Go OS, Windows and Go Arch AMD, Go build whatever, then Go will just take care of that for you and build a binary for that platform. So code just does that a bunch of times. If you say platform all, it will look into the base image you specified and say, oh, this base image has support for these 5 architectures. I will build in parallel for those 5 architectures and then put them on top of those base images. The default distroless base image supports 8 architectures out of the box currently. I think that might be changing. Might have changed since I wrote this, but basically in general, it looks into your base image and says, you want to build for these, or you want to build on top of these 8 platforms, I will build for those 8 platforms and put it on there. Similarly to before with the speed thing, you can do this with Docker build. You can do this, you know, you can configure this to do this as well with Docker build, but it's a bit easier to just add, you know, co-build platform all. Co also supports Windows images out of the box. So if the base image does have a Windows architecture, it will handle that too, which I think is a bit harder to do in Docker, but also not impossible. There's a very, very little bit of YAML templating integration. We didn't want to go all the way down the path of having like customize or something like that. You can use customize, you can use tools like that. But if you specify a string in a field of YAML that starts with co://, that's the Go import path that Co will build. So when it scans a YAML and like looks for this YAML file and says, oh, a Co signifier, I'll build that path and push an image and then replace this string with the resolved built image instead. So it will push that image and then put in its place that, and then output that through. So you can co-resolve, that's what the command that does this is, co-resolve some deployment and write it to a release YAML. You can pipe it to kubectl apply if you just want to directly apply it. And in fact, we have a little shorthand for that, which is just co-apply -f deployment.
Can you,
this has,
yeah,
go ahead.
sorry, I was gonna ask, like, can you also specify the version of the module that you wanna build? So for example, like whatever repo that you specified there, can you specify, okay, like this tag or this version is what I want to build?
I believe you can. Generally, this is done with local source. So like in your own application, you can do that. But I haven't actually tested it. I think it should work, but don't take my word for it. Normally, people are doing this with like a local repo with many modules or many applications in it.
And this is so this is like normal YAML templating, so it would work for any other YAML files that have this core signifier.
Yeah, it doesn't do anything Kubernetes specific. It's not parsing that it is a deployment in some way. It's not knowing that image is a special field. It just looks through YAML and says a YAML string value that starts with co:/. I'll take it and replace it. So yeah, you could do this in any YAML. Co also produces a software bill of materials by default. This is yeah. That's a good update, a good example. So when you Go build an application, the binary that Go produces includes the list of modules that you depended on in that binary. And so after Co builds that binary using Go, it extracts those dependencies and basically rewrites them into the SPDX format of an SBOM. So you can, or CycloneDX, and then pushes that SBOM to your registry alongside your images. You can use Cosign, or there's a few other tools that will do this too. You can use Cosign to download that SBOM and see, you know, Co's own dependencies are these packages listed here. I don't have much of a demo prepared, but I can go through one if folks want to. But basically, like I said, the real like sort of magic of Co is that it just depends on Go for a lot of stuff. We aren't a general purpose build tool. We aren't a general purpose image sort of construction tool. We really only do one thing, and we aim to do it really well. And that's because Go makes all of these things really easy for us. There's a bunch of other stuff I'm also not mentioning, but you can go to co.build to learn more about it. There's a couple similar things, similar related things. We use distroless as our base image, or chain guard images as our default base image right now. there's a GitHub action to install Ko for you and set it up. Jib is a very similar thing for Java. If you've been watching this whole thing and thinking, but I don't write Go, Jib is a similar tool for Java, and Conet is another one for .NET. But I think I've heard that .NET might be working on this sort of more built-in natively for the tool. So stay tuned. And that's Go. Yeah, I'm happy to answer any questions or sort of, I can go through a demo if you want. It will just be very rough because it will just be me messing around with Go.
I think this was good. I'm just like, so like you mentioned cosign, do you have any support for assigning images using maybe cosign for like images that are built using co-resolve?
Yeah, we don't currently, but it has been a long-standing feature request and something we definitely like to do. I think the way that this would probably work is to rely on, there's a number of sort of ambient credential providers. Like if you're running in GitHub Actions, that workflow has an identity, and you can use that identity to sign stuff. So using cosign, using SigStore infrastructure. So Ko should have a way. The way we're planning on it working is Ko would sort of look for credentials, identities that it could use to sign, and if it finds one, sign all the images it builds, and push those signatures to the registry, write those signatures to Recore. Yeah, we're planning very close integration with SigStore beyond SBOMs, but yeah.
Does anyone have other questions? I know like been mostly asking them. Oh, by the way, congratulations on getting into the CNCF sandbox. That's
Thank you. Yeah, that was also a long time coming, and I feel like I'm glad it happened. Happy to be here.
What are your plans after like being on the sandbox?
I think our main plans this year are to get that sort of signing integration done, and try to engage the community a little more, see if folks want to either adopt it or contribute to it. I think CNCF is going to be a good sort of marker of maturity for people to adopt it or start contributing. Oh, I see a hand up.
Yeah, hi. Thank you so much for the overview. I think I learned a lot from that. I did have one question, and this is just like from my brief understanding of Go. I am aware that Go gives you functionality to sort of include like static assets. I think like similar to how Go gives you directives to do that. So what I was wondering is like, if you do have a static asset and let's say that's like linked somehow, either like a hard symlink or a soft symlink, like I'm pretty sure it's there somewhere in the docs. But like, does it follow it somehow? Like what functionality does Go give for that? Because I know Go has some limitations over that. So like one over the other, if I had to like pick and choose.
Yeah. Excuse me. Ko does have support for bundling some static assets in the directory into the final image. I'll share this link actually in the chat, where it's sort of described in more detail. Ko's convention is that if there is a directory named kodata, when you co-build on their that application, it will take all the files in kodata and put them in another layer in the image. And it chases symlinks for that as well. So that is one approach. You could also use Go's embed functionality for this. There's sort of trade-offs and ups and downs of each of them. I think you mentioned that Go embed might not chase symlinks as well or in the same way. Ko's support for this, it predates Go embed by a couple of years. So we mainly added it because we found ourselves wanting this. And then Go embed happened and we were like, oh, we could do that too. I will say that the go embed approach wouldn't put it in a separate layer and wouldn't, yeah, it wouldn't put it in a separate layer. It actually embeds the contents of those files into the binary. It's sort of a trade-off either way. If you find that your application is changing a lot, but your static binary, so your static assets aren't changing a lot, then you might prefer Co's approach because you won't keep pushing a large binary with a bunch of unchanged files in it. But yeah, the docs there are well, okay. And if you have any questions, I should have mentioned this earlier. There's a co-build channel on the Kubernetes Slack if anyone has any questions after this or outside of this.
Yeah, that helps a lot. Thank you so much.
Sure.
I guess the last question I have is like, what do you think can folks do, or what are your plans to like drive adoption apart from being in the CNCF sandbox? I think it's already popular.
Yeah, I don't sort of have an idea of how popular it is already. I keep banging the drum and trying to tell people, you know, anytime I see a Docker file that just runs Docker or that just runs Go build, I'm sort of like, you should use Go, you should use Go. I think more adoption just comes from sort of more outreach, more things like this, like talking to folks, telling folks about the magic of Go. I think signing will help. I think, you know, if it's, we want to be the all-in-one, like you use this tool and it does everything right. It generates SBOMs, it signs stuff, it does everything. So more outreach, more features, more community hopefully will help. That's my general plan. Ideas welcome. If other folks have other ideas, I'm happy to consider them as well.
Cool. Does anyone else have questions? I guess we can call it a day and we can get 30 minutes of our time back. Thank you so much, Jason. This was great. So this will be recorded and I'll post the recording, or Ricardo will post the recording on Slack, and folks who want to follow up can follow up. So you said like if folks want to reach out to co-maintainers, that's a co-build Slack channel on the Kubernetes Slack. Is that right? Okay.
Yeah, that's right.
Sounds good.
Or file an issue, or, you know,
Yeah.
ping me or anything.
Cool. Thanks for joining, everyone. Bye-bye.
Yeah, thanks everyone.
Thank you.
Bye.
Bye.